Welcome to the next tutorial class. Today we will do some numerical problems on Poynting vectors. So, this is the first problem. So, given that vector electric field equal to ux by a square sin omega t and vector means magnetic field equal to u by x cos omega t, determined J t and mt. So, here J t is the total electric current density and mt is the total magnetic current density. And in the next part, determine IT and KT through the disk z is equal to 0 and x square plus y square equal to 1. So, first we will do this problem. So, here vector electric field is given ux by a square sin omega t and vector magnetic field is given u by x cos omega t. So, to find the means J t, total electric current density, J t we can find out by J t equal to del cross of J is equal to del cross H, and del in rectangular coordinates it can be written as del by del x ux plus del y u by plus del y del z uz, and this is cross with hy. So, hy is u by x cos omega t. So, here we can see that ux cross u by. So, this will give, so we know in rectangular coordinate system x by z. So, ux cross u by, it will give uz and del into del x, and x there here it is differentiation on x. So, it will give 1. So, this will come equal to, so in the first term it will come del upon del x, on x it will be 1, ux cross u by, it will be uz cos of omega t, and u by cross u by, it will be 0 because we know sin theta and angle will be 0 degree, and it will give means sin 0 0, and uz cross u by, it will be uz cross u by, it will be minus of ux, but del upon del z, here is here in the h term there is no z component. So, its differentiation will be 0. So, this will be the J t. Similarly, we can find out the mt. Mt will be minus of del cross E. We can write the del again. So, minus with minus sign this time del is upon electric field. Cross with electric field is ux by a square sin omega t. So, here in the first term ux cross ux, it will be 0, in the second term u by cross ux, this will be minus uz with differentiation with respect to del upon del y. So, this will come 2 by. So, from the second term it will be minus of and u by cross ux, it will be minus uz and then del upon del y. on by square. On the by square it will be 2 by and that sin omega t. So, that will be constant. So, this term will be m of t will be u z 2 by sin omega t. So, this is the m t. Similarly, in the question it is written determined I t and k t through the disk z is equal to 0 and x square plus y square equal to 1. So, I t we know, means how to find that electric current, total electric current. So, this will be, so I t will be integration on double integration, that surface integral on z t dot product with ds. So, we can substitute the value of z t, that is u by x cos omega t. No, z t is u z cos omega t. So, we can substitute that. So, double integral and here integration will on, means x is equal to, so here x square plus y square is equal to 1. So, if we will get like x is changing from 0 to 1. So, y will be from 0 to 1 minus x square and z t value is given u z cos omega t. U z cos omega t and ds. So, on the surface x on the surface z is equal to 0 and x square plus y square equal to 1, it will be dx dy into u z. Here dot product with u z, means dot product u z dot product with u z, it will be 1 and integration will on cos omega t dx dy. So, this will come cos omega t, it is constant, that is outside, and 0 to 1. So, here we can take on by, integral on by will be a square root of 1 minus x square into dx, and this will come pi square by 4, pi by 4 cos omega t. This is the value of I t. Similarly, we can find out the magnetic current k t. Magnetic current k t will be double integral on m of t into the dot product, it is with ds. In the similar way, we can find out m t value is u z 2 by sin omega t. So, we can write here again x is from 0 to 1 and y is 0, y is equal to 0 to a square root of 1 minus x square, and we can substitute the value of m t u z 2 by sin omega t, u z 2 by sin omega t dot product with dx dy into u z. So, this will come, means integral on y will be y square by 2 and 2 will cancel out, and in the final expression will come like this. Sin omega t is constant, integral on 0 to 1 minus, because that is y square, 1 minus x square into dx, and this will come 2 by 3 sin omega t. So, this is the k t. So, we can go to the next problem. Next problem is for the field of problem 1 determine the Poynting vector. So, this is one problem. For the field of problem 1 determine the Poynting vector, and next problem is show that del dot E cross H plus E dot J plus H t dot M t equal to 0. So, here it will be H dot M t. So, H t will not there. So, first we will do the first problem. So, problem 1 is determine the Poynting vector. So, Poynting vector we know. Poynting vector is defined as S equal to Poynting vector it is defined as E cross H, and E cross H. So, this is the cross product of electric and magnetic field. So, we can do like this U x U by U z and U x, means electric field is U x by a square sin omega t. So, that is that electric field has only x component. X component means that means by a square sin omega t. So, this is the electric field, and all other component will be 0, and H will be, it has only by component, that means x component will be 0, by component will be x cos omega t, x cos omega t, and z component will be 0. So, we can solve this matrix. So, we will take U x. So, it will be U x. So, this minus this. So, this 0 minus 0. So, this will be 0 u by this into this will also 0, u by will also 0. In the next part u z. So, u z will be plus u z, and inside it will come x by a square sin omega t into cos omega t minus 0. So, here it will be x by a square sin omega t and cos omega t. So, this is the total Poynting vector. So, S will be u z x by a square sin omega t cos omega t. So, this is the Poynting vector. In the next part we have to prove that del in dot E cross H plus E into J t plus H into M t equal to 0. So, we can derive that. So, del dot product with E cross H plus E into J t plus H. So, these are the vector H into M t. So, this equal to, so we know E cross H we know already derived. So, this will be dot product with del. So, del is u x plus del by u by plus del by del z u z, and this is dot product with E cross H. So, E cross H we already find out. So, this is u z x by a square sin omega t cos omega t. So, this is a del dot E cross H plus E dot J t. So, we can see that electric field H means value of electric field is ux by a square sin omega t, and that is dot product with J t. J t value is uz cos omega t plus H. So, H value is u by x cos omega t dot product with m t. So, m t is 2 by sin omega t into uz. So, in the first part we can see ux dot with uz, this will be 0, u by dot with uz, this will be 0. So, only this term will be there, del upon del z uz dot uz. So, uz dot uz it will be 1, but differentiation with respect to del z on x by a square sin omega t cos omega t, this will be 0, because there is no z term in the expression. So, for the first case it will be 0, for the second case ux dot with uz it will again 0, and third part u by dot with uz it will again 0. So, we derived, so total will be 0. So, this is the solution for the second problem. Now, we can go to the next problem. Determine the instantaneous quantities corresponding to this. So, in the A part I is equal to 10 plus j 5, for this term we have to find out the instantaneous quantities. So, we will do one by one. So, in the first case it is I is equal to 10 plus j 5. So, we can do the third problem. So, third is I is equal to 10 plus j 5. So, to find out the instantaneous quantity for this case we can write I equal to, this is for the complex and we are writing a small for the instantaneous. So, I equal to root 2 real part of I e to the power j omega t will give the instantaneous quantity for 10 plus j 5. So, we have to substitute 10 plus j 5 in the I expression, and we will express e to the power j omega t like cos omega t plus j sin omega t, and we will extract the real component, that will be the instantaneous quantity. So, we can write this as root 2 real part of 10 plus j 5 into cos omega t plus j sin omega t. So, real part of this we have to multiply this, means we have to multiply this. So, 10 cos omega t plus j, so this will be imaginary. So, let us do one, then we will do shortcut, root 2 real part of, so this will be, we are multiplying 10 cos omega t plus j 10, so this into this term j 10 sin omega t plus j 5 cos omega t, j square into j square, it will be minus 5 sin omega t. So, here we can extract the real part. So, this terms are imaginary part. So, instantaneous quantity real part of this will be a square root of 10 cos omega t minus 5 sin omega t. So, this will be the final answer, root 2 10 cos omega t minus 5 sin omega t. Similarly, we can do for the next part. In the next part, electric field is given, means E part is given ux. So, it is given. In the B part, it is given E equal to ux 5 plus j 3 e to the power j omega t plus u by 2 plus j 3. So, for this we can find out the instantaneous quantity. So, here we can denote like this, E equal to a square root of real part of vector E to the power j omega t. So, we can substitute the value of E here and we can again extract the real part. So, root 2 ux 5 plus j 3 and we can multiply inside e to the power j omega t plus u by 2 plus j 3 e to the power j omega t. So, here we can write e to the power j omega t as e to the power j omega t as root 2 real part of ux will be there. So, these all are the unit vector ux 5 plus j 3 cos of omega t plus j sin omega t plus u by, for the second term, 2 plus j 3 into cos omega t plus j sin omega t. So, here we can extract the real part. So, real part will be a square root of root 2. So, it will be outside in the bracket ux 5 cos of omega t and here j square is equal to minus 1. So, minus 3 sin omega t. So, this will be the only real component from the first part. In the next part, u by 2 cos omega t minus j square, again it will be minus 3 sin omega t. So, this will be the final answer. For the next part, h is given ux plus u by into e to the power j x plus pi. For this part, so we can do the next part. Ux plus u by e to the power j x plus y. So, for instantaneous quantity for this term, in the same way we can find out, equal to root 2 real part of h e to the power j omega t equal to, we can substitute the value of h, root 2 real part of u x plus u by u x plus u by e to the power j x plus y into e to the power j omega t. So, for this case we have to find out the we have to extract the real part. So, u x plus u y, so it will be root 2 real part of, we can write this first term as u x plus u by, it will be there, and this e to the power j x plus y, it can be written as cos of x plus y plus j sin of x plus y into cos of omega t plus j sin omega t. So, we can multiply these two and we can extract the real part. So, after multiplying we will get root 2 u x plus u by. So, here cos x, so real part will come from this term and this term. So, this will be cos of x plus y cos of omega t, and one more term will come from this multiplication and this multiplication. So, j square minus 1 minus of sin x plus y into sin omega t, and other two term will be, so this into this plus j cos of x plus y sin omega t, but these are the imaginary term, plus j sin x plus y cos omega t. So, final expression for this will be root 2 u x u x plus u by, so this will be outside, and because they are only real quantity, and after this we have to extract this term, first term. So, this will be cos of x plus y cos omega t minus sin of x plus y sin omega t. So, this will be in the bracket. So, this is the answer for the third part. Thank you.